Question 1A, anybody needs me to go through? Take out a paper quickly. 1A, anybody needs help? Hey, proving that they are similar. What answer you are expecting me to show you? You're supposed to prove that they are similar. Okay, 1B. Answer is 18 cm. So I assume part A nobody needs help. Farisha, have you finished? Okay, part C. Part B, okay. So I drew out the two triangles first. A, B, C, and over here is D. The lengths that I have are 8 and 2. Then I have another triangle, A, E, D. This is 2 and this is 5. Yuling, first you agree with me that these are the dimensions? Okay. Since they are similar triangles, the ratio of the corresponding sides will be the same. In other words, we are going to compare. We're going to compare this side with this side, and then this side with this side. Presentation wise, will look like this. A D plus DB, okay, meaning the yellow color part, divided by AE is equals to AC divided by AD. Then I substitute in everything that I know. So I get 2 plus DB over 8 equals to 5 over 2. Continue to solve, you get DB equals to 18 cm. Okay? Can or not? Then part C, the answer is 1 over 15. Anybody needs help for this? Runchen, have you done your work? Did you get 1 over 15? Now question 2. A part 1, we have half B plus A. Part 2, 3 over 4 A minus 1 over 4 B. Anybody needs help for these two? Then the showing part, anybody needs help? And then part C, showing triangles are similar. Anybody needs help for this? Ryan, you need help, is it? Okay. P and Q as well as L, M, O. Then, Ryan, do you agree that these two angles are the same? No, do you know the reason why? PQN as well as LOM. Go and find these two angles in your original parallelogram. Ryan, have you seen it already? Why are these two red angles the same? Anjali, do you know why they are the same? Runchen, do you know why? If you don't know why, go back to your diagram. PQN. PQN is over here. This is the angle I'm referring to. Then LOM. LOM. Where's M? M is over here. Go back to your diagram. These are the two angles we are trying to show that they are the same. And yes, it is clear because they are alternate angles. P, Q, as well as OR are parallel lines. That's where you get our parallelogram. So these two angles, they are the same already. Then what else can we prove that are similar? For proving of similarity in triangles, all we need will be two angles that are the same. Can you find me another pair of angles that we can prove quite easily? Use the ratio of length. Yes, it is fine also. Can we consider this? These two angles? We can, right? As long as we prove that they are the same, then I would have proven that the two triangles are similar. So these are the two angles. Now, the question is, how do we prove that they are the same then? Do they look like alternate angles also? Yes, they look like alternate angles. But are they parallel lines? How do you know? In the earlier part, you have proven that L. Yes, in our earlier part, we have this. NP is equals to 1/4 3A minus B. And then we have LM is equals to 1/6 3A minus B. They are parallel vectors. So NP parallel to LM. Since these two are parallel, then the green angles are the same, because again we are using alternate angles on parallel lines. Okay, so our presentation will be angle PQN equals to angle LOM, and we say that they are alternate angles, parallel lines.
So when you find LP equals to 1/3 minus B?
L what? LM. LP. I do have LP. Where do you see LP? Ryan. And P. Okay, that is one angle already. The other angle is angle PNQ equals to angle LMO. Again, alternate angles, parallel lines. So we just conclude. Triangle PNQ is similar to triangle LMO. What is your understanding of SAS test? Yeah, he's laughing because I told him about it. SAS test. We use this in our congruency test, right? Where we say that the side and the corresponding side must be the same length. And then another side with another corresponding side must be the same length. Angle is the included angle. So what do you understand about using SAS test for similarity? Is it the same thing?
No.
What is it about the S in your SAS test for similarity that you understand? Huh? Then how do you apply it? Okay, so because in your little notebook, right, that your little revision TYS book that's given to you, I think they also call it SAS test for similarity. They are referring to the ratio of the corresponding side for the S in the SAS test. Meaning, if I want to prove these two triangles are similar, I need to show that the ratio of PN to the ratio of LM is the same ratio as PQ to LO. That is the S and the S. Then this angle will be the A in between. Understand? SAS test for similarity. But because Mr. Tan told you during this chapter, we don't want to confuse you with so many names. So just remember that your SAS, SSS, RHS, ASA test, all for congruency. For similarity, we just show the two angles are the same. Then we prove that they are similar. Or we can show that two corresponding sides have the same ratio plus one equivalent angle, then we conclude that they are similar. We do not have to state whatever test for similarity. Yes, you can use a fraction to show. Okay. Did you write it this way? OM over NQ. Did you write it this way? Or do you have arrows? Huh? No arrows. Okay. No arrows. Okay. Okay, then you get what fraction? 2 over 3. Then after that, what else do you have? Also 2 over 3. Yes, this is fine. But what I cannot accept and what we do not accept will be this. OM as a vector over NQ as a vector. Then OL over PQ. Not acceptable. We cannot divide a vector by another vector. It is always the magnitude only. So if you really want to write the arrows, then you do this. Add in these lines to tell me you are referring to the magnitude only. Then part D, answer is 1 ratio is 1:3. Okay. Yeah. Area of OML over area of OQR is equal to half times OM times OL times sine QOR over half times OQ times OR times sine QOR. Remember that we taught you the different ways of finding ratio of areas. We said that some triangles are similar. So we can just use the square of the ratio of the sides. Then we also told you that some triangles have the common base. Then we just use the ratio of the base. No, they have the same base, so we use the ratio of the height. Some of them have the same height, so we use the ratio of the base. This is the other type that you need to know. They have a common angle, and you know the ratio of the sides. So we use half AB sine C. Notice that QOR and QOR over here, they are the same. So I do not need to evaluate. I can cancel. Half and half, I can cancel. I know the ratio of OM over OQ and OL over OR. So I'll replace them with numbers, and I will get 2 times 2 over 4 times 3, which is 1 over 3. So this is not a ratio yet. So my final statement will be ratio is 1:3. Okay? This type has not come out for some time already. This type of finding ratio of areas. Most common ones are what you have seen: ratio of height, ratio of base, similar triangles. Maybe this all will come out. Then next is question 3. 7.2 kilograms. Anybody needs help for this? Ipin, do you get it correct? Ipin, you get question 3 correct? Huh? When are you going to submit to me? Question 3, anybody needs help? Okay, then 4. A, 6.25. B will be 28 liters. Then question 5A, 24 cm. 5B, $1.25. Huh? Okay, if you want to put it in cents, it will be 125 cents. They didn't specify what to leave it in. Anybody needs help for these 2 questions? Vincent, show me your work. Show me your work. This one, everything.
You make me feel special.
Okay, done? 4 and 5?
Yes.
Alright, question 6.
Yeah.
Show that they are similar. Who needs help?
No one.
6b, 58 square centimeters. You need help. Okay, PML. Area of triangle PML over area of triangle LMQ. So this will be half times PL times H, half times LQ times H. Because these two triangles, they have the same height. You all see it? Go and highlight or trace over the triangles in the diagram that's given to you. Then you'll see that they have the same height. So once that is done, it's just a matter of cancelling again. Yep, this is equals to 4 over 20. And the height of PML was given 11.6. So just solve. Okay? Next, question 7. Part 1, 102 degrees. Part 2, okay, it's a showing question. Anybody needs help for that? Okay. Part 3, 15 square centimeters. All okay, this? Excellent. For those who have tried. Eight A, showing question. Need help? Okay, part B. Also showing. Anybody needs help?
No.
8B. Killer, okay? Then C, 55 degrees. Yes, Yulin also got it, huh? Then question 9, showing and proving. So need help? Need help, okay. Last question, huh?
Sure, is it like net angle?
Yes, Ziken, you're right. Yes. Excellent. So this is a square over here. And then I have another square. The trick, like what Ziken has mentioned, is we let this angle over here be x. And we are told that these are squares. Sorry? I missed another line. Oh, okay. We are trying to show that angle ADE. We want to show that this angle equals to CDG. So we can write out that ADE first. ADE is made out of EDG, which is a 90 degrees, plus angle GDA. Okay, this is equals to 90 degrees plus angle GDA. Then the other angle that they are trying to ask us to show is angle CDG. CDG. Okay, that is equal to angle CDA plus angle GDA again. So this is 90 degrees plus angle GDA. And we see that this is exactly the same as what is over here. So I'll put that this is equals to angle ADE, shown. But you did you write something like this? Then you're assuming that I realize that you are trying to compare the sum, right? Basically, what you're doing is okay, as long as you add in this step at the first part. Okay, then we can use the same proving method to show that the two triangles are congruent for another. Oh, we already have the two. We have the angle already. It is an included angle. So all we need to do is to prove that the other two sides are the same. So we'll be using SAS for part B. Okay, so that's all for this paper.